Alright, so if you do get lost at any point here, I'm recording this right now, so if you want to go back to this video, you can. It's really for people who are absent, but it's a resource for you too. Yep. Alright, so we're talking about intercepts. X and Y intercepts are basically just where our lines are hit, where our X and Y axis are hit by this line. Okay, so the Y-intercept is where our graph crosses the Y-axis. It's wherever our line happens to cross over the Y-axis. Every point on the Y-axis has an X value of what? What's our X value on the Y-axis? On this line, that line, what's the X value the entire time? So like, think about the coordinates there. What's the coordinates there? 0, I was marking 5, but yeah, 0, 6, 0, 1, 0, negative 1. The X value along that entire line is just 0. So the X value is always 0 along that line. And the intercept is just represented as a ordered pair. So you're going to write that as X comma Y, or really 0, and then I changed the notation there, but it really means the exact same thing. F of X, actually really F of 0. It's really just an ordered pair. This is a different way to say Y. That's all it is. That really helps us find the Y-intercept very easily. So when we're looking at a table, you just look for an X value of 0. What's the Y-intercept in that table?
Negative 6.
It's negative 6. I'm going to write it as an ordered pair. It's 0, negative 6. Wherever my X is 0, I know that's where it's hitting the Y-axis. I'm going to draw it on this graph just so you can see it. 0, negative 6 is hitting right there. That's along the Y-axis. That's all the Y-intercept really means. From a graph, it's really easy also. Where is that graph hitting the Y-axis?
4.
It's hitting at 5. It's close. I think it's really hitting at 5, though. So I'm going to write that as an ordered pair. 0, 5. From an equation, it's a little bit trickier, but it's really the exact same idea. I know that my X is going to be 0. So I'm really just evaluating that. F of 0 or X equals 0. That's going to tell me wherever my Y-axis, Y-intercept is. So all I'm going to do is take 0, plug it in for X. F of X, F of 0 equals negative 6 times 0 plus 4. You just follow order of operations. Yep.
Why is it important to find the Y-intercept?
Because it's going to help us find our equation really easily. Actually, it's also important to just know, like, when the X is 0, what's the Y value? Where does our graph start, basically? And actually, you can see it in that equation. Anytime our equation looks like this, Y equals mx plus b, that's our Y-intercept. We're going to talk about that more later. Right now, we're just thinking about it as plugging in 0 for the X, and then figuring out what that actually equals. So we would do the multiplication, and then plus 4. 0 plus 4 is just 4. So our Y-intercept is 0, comma 4. Not understand any of those three versions of that. It's really all the same information. Yep.
So there could be more than one Y-intercept?
There could be. Here there's just one, but there could be more than one. All right. What's the Y-intercept on that table?
4.
Yep, Richard. Yep, 0, comma 4. It's wherever the X is 0. It's the Y-intercept on that graph. Negative 1. It's wherever we hit that line. And I'm going to write as coordinates. If you wrote it as negative 1, I wouldn't mark that wrong. 0, negative 1. That's our Y-intercept. This is a little bit, it's basically one extra step now. When you're looking at an equation, you're basically thinking the x is 0, what's the y going to be? You're really evaluating this f of 0. We're plugging in 0 for both of these x's, 0 squared minus 11 times 0 minus 1. You can kind of see what that's going to turn into. 0 squared is just going to be 0. Minus 11 times 0, that's also going to be 0. So f of 0 just equals that negative 1 where it's just negative 1. Any questions? The x-intercept, it's the same idea. Now we're just talking about where it hits the x-axis. So wherever our graph or our table or our function crosses the x-axis. The most confusing part about this, I think, is just the terms that we can use for x-axis. There's 4 different words that we can use for this. The x-intercept, first off. The root. That's going to make more sense when we get into factoring. But a root is just another word for an x-intercept. Actually, solution also makes more sense later, too. Really, all of these make more sense when we're talking about factoring. We'll talk about that later, but all of these, solution, root, x-intercept, and it's 0, all mean the same thing. It's wherever the graph hits the x-axis. What's the y value of all of these points? Yeah, it's going flat straight across, so it doesn't have any up or down value. Y value is always 0. Again, it's an ordered pair. So we can write that as x comma y, or specifically, it's going to be x comma 0. So the y value is always going to be 0. So again, it's really easy to find from a table and a graph. We're really just looking at that table. Where is the y value 0? What's the x coordinate? Yep. 3, 0 is our x-intercept. And you can imagine that on the graph. 3, 0 is there. That's where that line would hit the x-axis. Where does that graph hit the x-axis?
1 comma 0.
Yeah, 1 comma 0. Actually, I should have talked about this. This is just another way to ask that exact same thing. What's the solution of that? It's 3, 0. What's the root of that?
3, 0.
That's 1, 0 on that one. The root of that one's 3, 0. Yeah. But root, solution, 0, x-intercept is just a different way to ask the exact same thing. This one's asking, what is the 0 of that function? Here it makes more sense, actually. What's the 0 of that? Basically, what x value turns this into 0? When we plug in 0 for the f of x, or for the y, what x value makes that equal to 0? I think that one kind of makes sense. What's the 0 of the function? What basically turns that whole thing into 0? How do we solve for x? What's that first step?
Subtract 4.
Yep, we're going to subtract 4. We're solving for x, so we're trying to get that by itself. We're going to subtract 4 and subtract 4. That 4 goes away. That just cancels out. This is going to turn into negative 4. And it equals negative 6. We're trying to get x completely by itself. Cancel out that negative 6 times the x.
Negative 6.
Yeah, we're just going to divide. Yep. That's multiplication right now, so you divide by negative 6. Make sure you include the negative sign there. It's dividing by the entire thing, the whole negative 6. You could write that as a fraction or a decimal. If you're going to write it as a fraction, you should be simplifying that. That's really the same thing as positive 2 over 3. If you feel more comfortable writing it as a decimal, that's fine too. So our coordinates are 2/3 comma 0. We found the x value when the y value equals 0.
What happens if it passes the x-axis?
Then we're going to have 2 x-intercepts. You're talking about this one?
Yeah.
Yeah, we're going to have 2 x-intercepts on that one. Everyone good on those 3?
Yes.
All right. What is the root of that function? Izzy, what's the root of that function? 4 is the y-intercept. Be careful there. That's the y-intercept. We're really looking for when y is equal to 0. Which one's that? When does the y equal 0? Yeah. Yep. -1 times 0. That's our x-intercept. And if you get these confused, the x and the y-intercept, if you're not sure about that, you can always just graph it. -1, 0 is there. 0, 4 is there. Our x-intercept is wherever we hit the x-axis. Alright, so Salvador, where are our zeros on this next one? 1 and 5. I'm going to write that as 2 ordered pairs. 1 times 0 and 5. You're allowed to have more than 1 0. You're allowed to have more than one y-intercept also. It's just wherever it crosses that line. Actually, we've seen graphs like this where it hits a bunch of times. So you can have a bunch of x-intercepts, that's fine. How do we find the solution of 0 or the root or the x-intercept on that one? What are we going to do there? Matthew, what are we going to do there? That we find a solution for that. For what? I think working. Not for the x, so it's for the f of x. You're going to put 0 there. Finding the y-intercept, we plug in 0 there. Finding the x-intercept, 0 is basically figuring out what makes this equal to 0. We're going to keep this the same, keep our x there. And now we're going to solve it. First step to solve it. Yep, here. Multiply by -2. Doesn't really change too much. This is going to cancel out, so we're just left with the top stuff there. This is still going to be 0. Ryan, what's your next step? Yep, add 9 over. You got 9 equals -3x. And Richie, what's our last step? Divide by -3. Yep. So our x is -3. If you're not sure how to write those coordinates, that makes it really clear. X is -3. And we know that this is just another word for another phrasing of y. So really our y equals 0. So it's just a matter of where you want to put this here. You want to put it into the x or for the y. All right. I'm going to just do 2 more examples of how to find the x and y intercepts. I know we have 2 weird kind of examples. We'll talk about those in a second. If I'm trying to find the x-intercept, or I'm trying to find the 0, or the root, or the solution. Matthew, where am I putting my 0?
In the x.
In the y.
In the y.
Yeah. If I'm looking for a 0, root, solution, or x-intercept, I'm putting the 0 there. So 2x minus 8 times 0 equals -24. Basically just cancels out the y term. So this is going to turn into 0. -8 times 0 is just 0. So I'm left with 2x. Not sure. This side. So I'm left with 2x equals -24. And what's the last step, Daniel? What do I do next?
Divide 2.
Yeah, divided by 2. So my x is -12. X equals -12. So my x-intercept is -12, comma 0.
Is it always going to be comma 0 or can it be comma?
For the x-intercept, it's always going to be comma 0. Yeah. For y-intercept, down, where do I put the 0 for the y-intercept? Yeah, I'm going to put it in for the x. So, okay, 2 times 0. This is basically just saying x equals 0, find the y value. So this time, that part cancels out. Got -8y equals negative 24. Change this by last step. Yep, make sure you divide by negative 8. Divide by negative 8. So y is positive 3. It's negative 24 divided by negative 8. That means my ordered pair is 0, 3. Because it's on that line, it's on this line. So my x value at each of those points is 0. Alright. X-intercepts. Lawrence, where do I put that 0?
Oh, you put it with the one.
Yep, where do you put a y? Y equals 0 basically means that's where it's going to hit the x-axis. So I got 0 equals negative 2 minus 4x. I really don't even have to write this. I know that's going to cancel out. I'm going to write it. I know that's going to be 6 times 0. So that's going to cancel out. I'm going to erase it now so I have some room. And how do I solve that equation? What would I do first to solve that? For Rylan, what would I do first? Yep, and 2 over. Negative 2, cancels out with positive 2. 0 plus 2, 2. That negative sign is stuck on that 4. Keep that, even though it was minus 4. Now it's a negative 4. And what's my last step? Yep, divided by negative 4. Make sure you include the sign. 2 divided by negative 4. Okay, so x, I'm going to simplify that. That's really just negative 1/2. So my x is negative 1/2. And my y is still just 0. Any questions on that at all? Matthew, where do I put my 0 when I'm looking at the y-intercept? Yeah, put it into the x. So I got 0 equals, I'm not going to write that middle term. I know negative 4 times 0 is just going to cancel out. I know that's just going to go away. So I'm just going to write this as plus 6y. Actually, it's the exact same steps. I'm still just adding 2 over and then dividing by the number in front of the y. So that's 2 equals 6y. And then divide by 6. I get that y is 1/3, or 2 over 6. If you want to write it as a decimal, that's fine. I got 0 over 0, comma 1/3. And now I got 2 special cases. We actually dealt with this when we were talking about domain and range. It might look a little bit different now, though. So y equals negative 6. That's just an equation of a line. What are the y values are always negative 6. It doesn't change. Y is always negative 6. That's what that's trying to say. Y is negative 6. It just is that number. X can be 0, x can be 10, x can be 100. It really doesn't make a difference. X is just always at negative 6. So I'm going to think about that as a graph. I said x is always negative 6. I meant y. Y is always negative 6. So x can be anything. Y is negative 6. I'm going to look at this just generally as a graph. 0, negative 6, 1, 2, 3, 4, 5, 6. 10, negative 6. I'm not going to actually draw those lines, but 10, negative 6 is somewhere over there. And 100, negative 6 is somewhere out there. So it's just a straight line going across. We kind of saw this when we were talking about domain and range. And that's how we would describe range. That's how we would think about the range. What's the x-intercept on that? We don't have one. You could say no solution. You could say none. However you want to say that. There is no x-intercept. It just never hits the x-axis. It's going straight across forever. It's never actually going to hit the x-axis. What's my y-intercept? Negative 6. It's just hitting right there. Negative 6. So 0, actually I even wrote it in the table, 0, -6. That is my y-intercept. On these kinds of lines, when you have y equals a number or x equals a number, you're going to be missing one of these parts. It's either not going to hit the x-axis or it's not going to hit the y. Well, that's not entirely true. It could also be on the x-axis and hit at every single point. We'll talk about that later, though. And we're really graphing lines. We'll talk about that later. All right. If x equals 10, it doesn't matter what y is. X is just 10. So if I'm filling in that table, x is just always 10. X equals 10 no matter what y is. There is no y value there. So x can be -100, 0, it can be 50. Doesn't really matter. X is always the same number, it's just 10. So 3, 4, 5, 6, 7, 8, 9, 10. I'm going to think about these points just generally. 10, -100 is down there somewhere. 10, 0 is right there. And 10, 50 is up there. What's my x-intercept? Where does that hit the x-axis? Yeah, it's really just hitting at 10. It's that point there. 10 down to 0 is my x-intercept. What's my y-intercept? Yeah. Don't have one. It never hits there. It's parallel to the y-axis. They never touch. I'm going to write it as no solution. You could also say none. It means the same thing there. Just think about where our lines hit the x and y axis in 3 different ways, as a table, graph, and as an equation. Okay, do this practice on your own.